Hello guys. Um, Please subscribe my channel for the GATE classes. In the previous class, we have studied about the open circuit faults. What is the effect of the open circuit fault? So that is due to the open circuit fault, over voltages will be caused. So that is the effect of the open circuit fault. Now let us analyze how the over voltages will be found. Let us see the analysis of the open circuit. So let us get back into the third class. So today's class 3 analysis. So analysis of the open circuit fault. So any equipment can be analyzed as in two ways. Any equipment can be analyzed in two ways. So the first one is conductor, and the second one is insulation over the surface of the conductor. Second one is insulation over the surface of conductor, let us say. So these are the two ways we can analyze the open circuit faults. So what happens in open circuit faults? When the open circuit faults arises, what will happen? That is, let us see. First, let us see what is conductor. What does it do? So let us see this diagram once. So this is the cross section, and this is, let us say, this is the conductor. So over a conductor there is an insulation. So let us say this is the insulation. This is the area of cross section, and this is insulation. So now, what is the purpose of this conductor? So the purpose of this conductor is to carry current. That's it. Is to carry current. The purpose of the conductor is to just carry current. Now, what is the purpose of this insulation? So, what is the purpose of this insulation? So, this insulation avoids leakage currents. Avoids leakage currents. The insulation avoids leakage currents. So, what happens then? So, basically, this insulation is nothing but this is the area of cross section. This we have discussed. So the size or the area of cross section of the conductor is based on the current carrying capacity. So whatever this cross section is there, so that is mostly based on the current carrying capacity. So this is based on current carrying capacity. Current carrying capacity. So this is what is one more point. This is regarding the conductor again. Now let us go for the insulation. So how much thick is this insulations to be? So that is the one of the criteria now. So the thickness of this insulation is based on the thickness of this insulation is based on operating voltage. Operating voltage. So depends upon the operating voltage, the thickness of the insulation is varied. So this is what is one more point. So these may be asked in the gate also. So just make a note of it. So then what is a consequence of the open circuit? Open circuit causes, open circuit fault causes operating voltages. I mean the heavy voltages. So it results in over voltages. So due to that, what happens? So when the over voltages, so which one is going to affect? Of course, the thickness. I mean the insulation is going to affect. So the insulation may get damaged due to over voltages. So here is one more point. Due to over voltages, it may damage the insulation. The insulation may get damaged. So this is one point. So this is the analysis of the open circuit fault. So due to the over voltages, I mean when the open circuit fault takes place, it rises in the over voltages. So when the over voltages arises, then the insulation of the conductor over the surface of the conductor gets damaged. So what happens then? So when the insulation gets damaged, then immediately the leakage currents among the conductor increases. Leakage currents among the conductor increases. So it allows the leakage currents. The conductors allows the leakage currents which is undesirable. So this is the effect of the over voltage I mean the open circuit fault. So now let us talk one more thing. So when we consider an open circuit fault, when we consider the open circuit fault, so when we say it is an open circuit fault, so that is one more important thing. So when we consider open circuit fault, so there are three cases we have to see the three cases to find which one is open circuit fault. Sorry. Now let us see the case 1. So what happens in the case 1? So as we know, a circuit typical line diagram is like this. So this is R phase, this is Y phase, this is B phase, R, Y and B. So the case 1 is when any one of the phases out of the three phases, if any one of the phase got disconnected, so that may be due to the loss of lines, so in the practical time. So if there is any one of the phase gets disconnected, then it is considered as open circuit fault. Then coming to the case 2, so let us say here is one open circuit here. Next case 2, out of three phases, if any of the two phases got disconnected, so this is what is the second case. let us say I am taking R and B. R and B are open circuiting. Not only R and B, any of the two. So this is also considered to be an open circuit fault. It raises the over voltages over here. Now let us coming to the case 3, third case. If all the phases R, Y, B got open circuited, all the phases R, Y, B got open circuited, then how can you consider this? Here any, here also any one. So if all the three phases got disconnected, then you cannot consider this to be open circuit fault. This is not an open circuit fault. It is not considered open circuit fault because here the synchronous generator is operating in no load condition. Here the load is not connected, hence there are no losses. Can't say that is a fault. So there won't be any fault in this case because the situation is like this. The synchronous generator is operating on no load. It's a no load operation of the synchronous generator. So that is what you can say, but it is not considered to be an open circuit fault. So this is what is the analysis regarding the open circuit fault. Now we'll meet in the short circuit fault in the next class. Don't forget to subscribe my channel RK Gate Tutorials and stay tuned for the further classes. Thank you.